geobyte.
Dear students, I hope all of you clearly understood all the theory concepts what we have discussed for rotational motion. Understood or not? Yes. Then let us take the previous year questions. Look at the very first question. It is asking like this. A circular disc reaches from top to bottom of an inclined plane of length L. It is like this. Let the inclined plane. This is the base for the inclined plane. Let me write it clearly. This is the base. This is the base and this is the plane. It is given that a circular disc. Let us mark the circular disc at the top position of the plane. This is the circular disc. Circular disc. Assume the radius of the circular disc is r, and it is given that length of the inclined plane is L. Small l be the length of the inclined plane. Okay. Then when it is slipping down the plane, it takes t seconds. When it slips down, when disk is slipping down, when the slipping is happening, the time taken by the disk is t. The time taken is t. Okay. When it rolls down the plane, then it takes alpha by 2 whole power 1 by 2 times the t seconds. When the disk is when disk is rolling down, it is taking the time t dash equal to alpha by 2 whole power 1 by 2 times the t seconds. Is it correct? Alpha by 2 whole power 1 by 2 times the t seconds. Correct. Then where alpha is, what is the value of alpha? Okay. For that, let us consider the angle between the base and plane is theta. Okay. First, let us take the slipping condition. When it is slipping down, the distance traveled by the circular disc S equal to ut plus half at square. Since initially the disk is at rest condition, initial velocity u equal to 0. If initial velocity u is 0, ut is becoming 0. Distance traveled by the disk is length of the plane only, equal to half into a into t square. What is the acceleration of the disk in the inclined plane? We have clearly discussed with the theory concept g sin theta. Okay. Then when it is slipping down, acceleration is g sin theta. From this I can write that t square equal to 2l by a, that is equal to 2l by a equal to what? G sin theta. Then the time taken for slipping down equal to 2l by g sin theta. 2l by g sin theta. Okay. Let us write for slipping down, we have decided the time required equal to 2l by g sin theta. Correct? Na? Let us cross check case. Absolutely correct. Then let us take the other case when the disk is rolling down. For this case also, the distance traveled by the disk equal to ut plus half a dash t dash square, because acceleration is not same for both and uh, rolling motion and slipping motion. For slipping motion, acceleration is g sin theta, whereas for rolling motion, acceleration a dash equal to g sin theta, g sin theta by 1 plus k square by r square, where k equal to radius of gyration. That radius of gyration k equal to, let me write it clearly, the radius of gyration k equal to, right, r by root 2, r by root 2. So a dash equal to g sin theta divided by 1 plus k square, r square by 2 r square, r square cancel, a dash equal to g sin theta divided by 1 plus 1 by 2, it is equal to g sin theta divided by, it is 3 by 2, 3 by 2, it is equal to 2g sin theta by 3. That is the acceleration while the disk is rolling down. Since the disk is starting from 0 speed at rest condition, therefore u0, then the distance traveled is nothing but length of the plane only, equal to length of the plane remains same whether the disk is slipping or rolling. L equal to half into a dash. Look at the a dash, 2g sin theta, 2g sin theta by 3 into t dash square. From this I can write that t dash square equal to, t dash square equal to 6l by 6l by 2g sin theta, 2g sin theta. It can be also written as 3 into 2, 3 into 2 equal to 6 into L by 2g sin theta. Therefore, T dash equal to time required for rolling down equal to root over 3 into 2 into L by 2 into g sin theta, g sin theta, g sin theta. Okay, the T dash equal to, it can be written as root 3 by 2, root 3 by 2 into 2l by g sin theta. But look at the root tl by g sin theta. Look at the root tl by g sin theta equal to t only. So finally it is equal to root 3 by 2 times the time required for slipping down. Therefore time required for rolling down equal to uh, 3 by 2, 3 by 2 whole power 1 by 2 times the t. But it is given, what it is given, time required, a minute, time required is given, t dash is given alpha by 2 power 1 by 2 into t. You compare with 3 by 2 whole power 1 by 2 t. Therefore alpha equal to what? Alpha equal to 3. I hope all of you clearly understood. Understood or not? Yes. Then let's take the another important question. Try to read it clearly. It is asking like this. A heavy iron bar of weight W is hanging its one end on the ground and other end on the shoulder of a person. So let this is the ground. This is the ground, and right on the shoulder of the person, on the shoulder of the person, right? The other end is lying. It is like this. This is the iron bar. Let this is the iron bar. This is the person. This is the iron bar. Okay. The iron bar weight is given W. You know, through the center of gravity, the self weight of the through the center of gravity, self weight of the iron bar is acting vertically downwards. This is the double. Okay. Then the bar makes an angle theta with the horizontal. This bar is making an angle theta with the horizontal. The weight experienced by the person. What is the weight experienced by the person? That means what is the weight carried by the person? That is the question. For that, let us assume the length of the bar. You extend this line like this. Length of the bar is L. Length of the bar is L. Then let the height of the person is H. A, B is the base. BC is the height of the person. Now I can write that sin theta equal to sin theta equal to sin theta equal to h by L. Similarly, cos theta equal to cos theta equal to AB by AB by L, distance side by hypotenuse. From this AB equal to L cos theta, L cos theta. Similarly, with respect to the weight, let this is the T. Right? Since the self weight is acting through the center of gravity, exactly at center, the AD equal to AD equal to AB by AB by 2. AB by 2. Okay. So then AD equal to AB by 2. That means L cos theta divided by 2. Okay. Having this information, let us mark the normal reaction. Normal reaction at the ground level, since the ground is right horizontal, this is the normal reaction. Let that normal reaction is N. Similarly, for the person also, this is the normal reaction. Let that is R. Then let us take the momentum about the about ground. Let us take the taking taking moments about ground. That is A. Moment means product of force and perpendicular distance. Look at the force developed as a normal reaction with respect to person R. That R is right acting vertical upwards. The perpendicular distance for vertical force is horizontal distance. Therefore, R into we are taking the momentum about A. Here it is developing two momentums. One is the normal reaction with respect to person. Other one is self weight by the body. The W into AD is developing the anti-clockwise momentum, whereas normal reaction into BA force into perpendicular distance is developing clockwise moment with respect to A. The condition for equilibrium is sum of the clockwise moments must be equal to anti-clockwise momentum. Therefore, the R into AB equal to W into AD. But what is the AD? AD equal to AB by 2 only. AD equal to AB by 2 only. So R into AB is equal W into AB by 2. AB by 2. The this AB, AB cancelled. Finally, the normal reaction at the person equal W by 2. Therefore, weight carried by the person equal to W by 2. Look at the options. Look at the option B. Option B is absolutely correct. Understood clearly? Yes.
Geobyte.